Hello dear all students. Today we are going to discuss about the basics of engineering thermodynamics. The subject engineering thermodynamics applies to a wide variety of topics in science and engineering, especially physical chemistry, chemical engineering, mechanical engineering, but also some of the complex fields like metrology. The initial application of thermodynamics was towards the mechanical heat engine, mechanical heat steam engine, in which the study was done on the performance of heat engine, means how we can increase the performance of heat engine. Then this study is extended to a chemical compound and the chemical reactions occur within the system and surroundings. Again, we know that many of the practical applications or many of the engineering device in our day-to-day lives that we use in our day-to-day lives are works on the principle of thermodynamics. That's why the thermodynamics is a very vast subject and that is included in our field of mechanical engineering. So these are the contents for our today's session. Introduction to engineering thermodynamics, review of some basic definition related to the thermodynamics, different types of thermodynamic systems, thermodynamics property, thermodynamics equilibrium, and thermodynamic processes. So let us start with the today's session. Thermodynamics. The word thermodynamics is derived from a Greek word thermo. The meaning of thermo is heat, and dynamics means either motion or power. We know that heat is nothing but the one kind of energy, and dynamic is nothing but the transfer of that energy from one position to the another position, or movement of one object from one position to the another position. So collectively we can say that thermodynamics is a study of energy transfer. So let us define the thermodynamics as: thermodynamics is a branch of science which deals with the study of different form of energy and their interconversion. So this is how the meaning of thermodynamics is. Why we study the concept of thermodynamics? There are the three basic reasons due to which we study the concept of thermodynamics. The first reason is spontaneous process. As we know, the number of processes happens around us. In all these processes are either naturally occurring process or some of the artificial process. Means all these processes are quickly responds to the variation in the parameters, right? And during this process, some of the energy changes in physical and chemical form. Thermodynamic tells us how this process can be happens. The second reason is feasibility. Feasibility. It provides the information regarding the feasibility of chemical reaction or physical changes. If the certain process is feasible, then how much extent it is possible. Now let us take one example. Let us consider a system in which a certain quantity of heat is supplied to the system, and the system produce a particular useful work that is equal to W. But in some of the case, whatever the amount of heat is supplied to the system, that is not completely converted into the work. Means in that case, some amount of heat is lost from the system. Means in that case, how much amount of work that we can extract, that gives by the feasibility of that system. Means thermodynamic tells us whether a particular reaction is possible under the given set of conditions, and that conditions are nothing but pressure, volume, and temperature. The third and most important reason is the effect on the surrounding. We know that the thermodynamic involves the number of processes, right? And all these processes have a particular effects on its surrounding. Whether the effect on the surrounding is good or bad, this can be studied in the subject of thermodynamics. So these are the three possible reasons due to which we study the concept of thermodynamics. Energy transformation. As we have already said that the thermodynamics deals with the energy transformation and the energy interconversion. So these are the few examples in which the one form of energy is converted into the another form. So in this first example, here we can see that the chemical energy of lead acid battery cell is converted into the light energy. In second example, the chemical energy of fuel is converted into the mechanical energy. And these are the some another example in which the one form of energy is converted into the another form. Approach to the thermodynamics. So in case of the thermodynamics studies are undertaken by the two different approach. The first one is macroscopic and another one is the microscopic. The meaning of macro means big or total, whereas the meaning of micro is small. So let us discuss the difference between the macroscopic and microscopic approach. So let us first discuss the macroscopic approach. In this approach, the certain quantity of matter is considered without taking into the account the events occurring at the molecular level. Means in other words, we can say that approach to this thermodynamic is concerned with the gross or overall behavior of the system. Whereas in microscopic approach, the system is considered that it is made up of a very large number of discrete particles, and that discrete particles are known as molecule, and these molecules have different velocities and different energies, and the values of this energy are constantly changing with respect to time. And we can say that approach to the thermodynamics is concerned directly with the structure of matter. So in microscopic approach, we consider the system as a gross volume, and in microscopic approach, we consider that the system is made up of number of discrete particle and molecule, and we study the energies and velocity at the molecular level. That's why the macroscopic approach is called as the classical thermodynamics, whereas the microscopic approach is called as the statistical thermodynamics. For analysis of macroscopic approach, a simple mathematical formulae are required, whereas to analyze the system under microscopic approach, the advanced statistical and mathematical methods are required to describe the system. So we can say that here the few properties are required to describe the system under macroscopic approach, whereas the large number of variables are required to describe the system. Means macroscopic approach is quite simple, whereas the microscopic approach is quite complicated. So we can analyze the thermodynamic system under these two approach. Though these two approaches are different, but there is some relation between the macroscopic approach and microscopic approach. When we apply these two approaches to a particular system, then whatever the result means final results obtained from the system are same. Only the how we can analyze the system is the process is the different, but approaches gives the same results. Under the macroscopic approach, the system under macroscopic approach, and system under the microscopic approach. So these are the two different approaches to the thermodynamics. Terms used in the thermodynamics. System. System is defined as a finite quantity of a matter, space or area on which the study of energy transfer and energy conversion is made. Means a certain quantity of matter from the space is taken under the consideration for the study purpose. So let us consider this is the system. This is the part of a space on which the energy transfer and energy conversion is made. Second is boundary. The system and surrounding are separated by a boundary. System and surrounding are separated by a boundary, and the boundary of the system may be fixed, movable, real or imaginary. Means whatever the changes occur within the system, depending upon that changes, the boundary of the system may be fixed or movable or imaginary. So this is nothing but the boundary of the system. The third one is surrounding. Anything outside the system which affects the behavior of the system is known as surrounding. Anything outside the system in this area, anything outside the system is called as surrounding. So this is surrounding. Collectively, system plus surrounding collectively called as universe, and as we know that there is nothing beyond the universe, means all these changes happens within the universe. So this is the three different terms. The fourth term is control volume. It is the volume of a system or any thermal device which has mass flow and energy flow in and out of the system. Means the quantity of volume in which the mass and energy flow in and out of the system. Mass and energy can flow in and out of the system. That volume is called as the control volume of that system. Control surface. The surface enclosing the control volume is referred to as a control surface, or the surface beyond which mass and energy can cross the boundary of the system or control volume, that is called as the control surface. So this is nothing but the control surface beyond which both the mass and energy can cross the control volume. So these are these five basic terms which are used in the thermodynamics. Thermodynamic systems. Thermodynamic systems are classified in four different categories: open system, closed system, isolated system, and adiabatic system. So let us discuss one by one. First one is open system. Open system is that system in which both the mass and energy can cross the boundary of the system. That system is called as open system. Second one is closed system. Closed system is that system in which only the energy can cross the boundary of the system, but mass cannot cross the boundary of the system. That system is called as closed system. Third one is isolated system. Isolated system is that system in which neither energy nor mass can cross the boundary of the system. Means neither energy nor mass can enter in and out of the system. That system is called as isolated system. The fourth one is adiabatic system. Adiabatic system is generally thermally insulated from the surrounding, from its surrounding, in which only the work can cross the boundary of the system. Only the work can cross the boundary of the system. When if this work is not cross the boundary of the system with the surrounding, then adiabatic system becomes isolated system. Adiabatic system becomes isolated system when there is no exchange of work with the surrounding. No? So these are the four basic different types of thermodynamic system: open system, closed system, isolated system, and adiabatic system. Classification of system on the basis of nature of constituent. So on the basis of nature of constituent, the systems are classified as homogeneous and heterogeneous system. So let us first discuss homogeneous system. Homogeneous system, all the constituents are present in same phase and composition of the system is uniform throughout. Yes, here we can see that the composition of the system is uniform throughout, means molecules are arranged in the uniform order, one after the another. So examples of homogeneous system: mixture of salt and water. As we know that salt is dissolved in the water, so molecules can be arranged as like this. Metal alloys. Metal alloys means combination of two different metal can be produce a alloy. Metal alloy is a homogeneous system. Saline solution again have the uniform composition throughout. So these are the example of homogeneous system. heterogeneous system. The constituents are present in two or more phases and the composition is not uniform throughout. Means the mixture of two different phases. Means solid and liquid can be treated as a heterogeneous system. So in this way, the molecules are arranged in the random order. Molecules can be arranged in the random order. Their system becomes heterogeneous system. So few examples: mixture of water and oil, mixture of ice and water and sand. These are the example of heterogeneous system. Thermodynamic property. Thermodynamic property is defined as any measurable or observable characteristics of the substance when the system remains in equilibrium state. Means a substance within the system has the different property. And what are the different property? The properties are like pressure, temperature, density, volume, energy, melting point, boiling point, conductivity, etc. But these are the property associated with the substance, and all these properties can be classified into different categories. Means property are classified as either intensive property and extensive property. So first discuss intensive property. Intensive properties are those whose value does not depend on the mass of the system. Whose value does not depend on the mass of the system. Those properties are called as intensive property. Means temperature does not depend on the mass. Again, the pressure does not depend upon the mass. Again, we will see some different example. Luster. Luster. Let us take an example of diamond. A 50 gram of diamond has the luster as like the 100 gram of diamond. Again, the another property is malleability. The property of material to drawn into the sheet does not depend upon the mass. Ductility. The property of wire to drawn into the property of material to drawn into the wire is called as ductility. Again, this does not depend upon the mass. Color does not depend upon the mass. Conductivity, right, does not depend upon the mass, right? Means 100 meter of wire has same conductivity as like the 50 meter of copper wire. Means conductivity again does not depend upon the mass. Boiling point and melting point. 1 kg of water has the same boiling point as like the 50 kg of water. Means boiling point and melting point does not depend upon the mass. Second is extensive property. Extensive property are those whose value are depend upon the mass of the system. That property are called as extensive property. So these are the few examples: volume, weight, size, and length of the substance. Well, these are the few examples of extensive property. Thermodynamic equilibrium. So these are the three different types of thermodynamic equilibrium: thermal equilibrium, mechanical equilibrium, and chemical equilibrium. A system is in thermodynamic equilibrium if the temperature and pressure at all the points are same. There should be no velocity gradient. The chemical equilibrium is also necessary. Then and then we can say that a system is in thermodynamic equilibrium. If a system under a temperature and pressure equilibrium but not under the chemical equilibrium, then system is said to be in metastable equilibrium condition. So for attaining the state of thermodynamic equilibrium, these three different types of equilibrium will be achieved by the system. Then and then we can say that the system is said to be in the thermodynamic equilibrium. The word thermal equilibrium. The temperature of the system does not changes with respect to time and has same value at all the point of the system. Then the system is in the thermal equilibrium. Mechanical equilibrium. There are no unbalanced force within the system or between the surrounding. The pressure in the system is same at all the points and does not changes with respect to time. Then the system is in the mechanical equilibrium. chemical equilibrium, no chemical reaction takes place in the system and the chemical composition which is same throughout the system and does not vary with the time. Then and then the system is said to be in the chemical equilibrium. From these sketches, we can able to learn the concept of thermal equilibrium, mechanical equilibrium, and chemical equilibrium. After here, when a cold body comes in contact with the hot body, then after a certain time, these two bodies have the same temperature. Again, here in case of mechanical equilibrium, we apply the equal and opposite force to a certain object, then that object will remains in the equilibrium state. Here we can say that unless and until this wall is not open, then this system will be in the chemical equilibrium. So these are the three different types of thermodynamic equilibrium. Types of process. So process is nothing but the path by which the system changes from one state to other state. And during the change of position of system from one state to the another state, the process is occur. Right? There are the four different types of process under the thermodynamics. The first one is isochoric process, which is also called as the constant volume process. A process in which the volume of the system remains constant. That process is called as the constant volume process. Means we can say that for isochoric process, change in the volume during the process equal to 0, and this process is carried out in a closed vessel. Second process, isobaric process. A process in which the pressure of the system remains constant. That process is called as isobaric process. Right? Means for isobaric process, change in the pressure is equal to 0, and this process is carried out in open vessel. The third one is isothermal process, which is also called as the constant temperature process. A process in which temperature of the system remains constant. That process is called as isothermal process. And for isothermal process, change in the temperature delta T is equal to 0. Right? So we can say that this is the isothermal process. Fourth one is isentropic process. Isentropic means constant entropy process. A process in which the entropy of the system remains constant. That process is called as isentropic process. So these are the four different processes that occurs in the thermodynamic system. So to plot the PV and TS diagram for the isochoric process, isobaric process, isothermal process, and isentropic process, let us assume the blue line indicate the PV diagram and red line indicate the TS diagram. So these are our four different processes: isochoric, isobaric, isothermal, and isentropic. So this is how we can plot the PV and TS diagram. Let us take example first process, isochoric. Meaning of isochorics, constant volume. Means during this process the volume of the system remains constant. So 1 to 2 process represent constant volume process on PV diagram, right? So on TS diagram, 1 to 2 process mean during the isochoric process the temperature of the system increases and the entropy of the system is also increases. So this is how we can plot the PV and TS diagram for the different process. So this is how the shape can be formed when we plot collectively the PV and TS diagram for isochoric, isobaric, isothermal, and isentropic process. So keep this in mind. Keep this in mind. The tail of any process as a initial state, whereas the head of any process as a final state of the system. So this is how we can plot the PV and TS diagram. And the last is cyclic process. Any process or series of a process whose end state and initial states are identical is termed as a cyclic process. When a system undergoes the number of processes and during the transformation of process, the system regains its original state, that process is called as the cyclic process. So this is how we can plot the cycle for any thermodynamic system. When a thermodynamic system undergoes a series of processes like 1 to 2, 2 to 3, 3 to 4 and 4 to 1, and during this transformation of process, initial and identical state, initial and final state becomes identical, then that process is called as the cyclic process. So these are the basic terminology used in thermodynamics, as we have learned the different processes, properties of the thermodynamic system, and the different